Hello everyone, welcome back. In this video, we're going to learn how to do IoT using MicroPython. MicroPython is a lightweight version of Python that runs directly on microcontrollers as firmware. It allows us to write Python code to control hardware like LEDs, sensors, and others on boards such as ESP8266. Let's now set the environment. We need to make sure we have Python. Let's check if we have it. I have it. So what if you don't have it? You will go download it. Here. You download it and then install it. While installing Python, remember to make sure you add Python to the path. Use a variable path, then you add it if you don't have it. For us, we have it already and we even have the scripts. Okay. Okay, now that we have Python, let's check if you have pip. Let's check if you have pip for managing the packages. Let's check if we have it. We have it. And what header do we need for today's practice? We need ESP tool that we'll be using for flashing the firmware. Let's use pip because pip is here to help us manage Python libraries or Python packages, as we normally call them. Let's check pip show ESP tool. Yes, here I have it, but for some reasons, if you don't have it, we can install it. Pip install ESP tool. Yeah, and because I have it, nothing to install. What else do we need is mpremote. Because after flashing the firmware or the on the device, we'll need to interact with the MicroPython running on device. So we need the mp remote. mp for MicroPython remote, mp remote. So do I have it? Because the last time I checked, I had it. So pip show mp remote. I got it, but if you don't have it yet, you can install it or pip install mp MicroPython remote. Nothing to install because I already had it. Okay. What else do you need? Now we need the firmware. You need to go to we need the firmware for ESP8266, and it's here. You just click and download it. I already did, and I already saved it to my desktop as ESP8266 FW for firmware dot binary bin. Okay, so I know it's there. You can save it wherever it will be easy for you to get it. Okay, so what else do we need in setting the environment? We just need to connect the device. Okay, and the device is physically connected. I have to check its port, the port took, because when the device is connected to your computer, it will have a port assigned to it. So there is the command mode to check the port assigned to this device, actually ESP8266. This is the ESP8266 that I'm talking about. Okay, so it's the computer assigned port COM21 to the this device. We now need to flash using the SP tool. Okay, we'll do it soon. And we can talk about flashing without talking about the bootloader. So, have you ever heard of the bootloader? The role of the bootloader is to welcome uh, the firmware or the device. It will welcome the firmware and it will point to the memory location where the firmware need to be flashed. Okay, so we can now flash. Then after flashing, we'll test. That's all. We can now start flashing. These are the commands we need to flash. We need to first make sure we erase the existing flash. So let's erase the existing flash. We'll use ESP tool and erase dash flash. But we need to first define port to which we want to do so. Port, it's COM21. It's done. Okay. Now there's no flash on the device. Now we can write the firmware, the MicroPython firmware. How we use ESP tool. We use ESP tool. We define the port to which we want to write. It's COM21. We define the baud rate we want to use. It's 46800. Then we write flash, we write flash, and which size? Flash size will be automatically detected, and it will be written to the 0 address. It means to the beginning of the memory allocation. For MicroPython, it's mandatory to write starting with the beginning of the memory. We don't need to skip any address. We immediately start at the zero address or 0 offset. So what are we writing? It's the binary that we saved on the desktop as ESP8266 firmware. So let's hit enter. It's happening. It's writing. It started from 0 and it's done now. It says it started at 0 and it took us 12 seconds to write. Okay. Now the firmware is flashed. Let's use mpremote to interact with the Python, the MicroPython on the device. Let's type mpremote, then port is com21. Oh no, mpremote connect to com port 21, then REPL. This is a tool for interacting with the MP remote, or I mean the MicroPython on the device. REPL stands for read, evaluate, print, and then loop. Do it over and over. Read, evaluate, print, and loop. Well, it's yeah, as simple as that. So this tool comes built in within MP Remote. So now we're connected to the MicroPython. This program is running right on the device. So we can start interacting with the device. For example, we can, from machine, we can import pin, and we can, from time, we can import sleep. Okay, we can define the variable LED and LED is pin. Let's use pin 2. Pin 2 is a pin that controls a built-in LED. It can, yeah, it means you can control it without necessarily connecting external LED, and you will see it. On the Arduino Uno, it's pin 13, where you have a built-in LED. So let's use pin number 2. You can see it on device immediately, or you can connect to the same pin the LED that you can see as well. Okay, so it's, of course, it's pin mode, it's out. Then let's control it. Let's say we want to turn LED on. It's on now, as you can see. Or we can turn it off. It's off now, as you can see. We can blink it 10 times. Like for I or N in range 10, LED value 1, let me turn it on, then sleep for a second or a half second, then LED value off, then sleep for a half second, then okay, then it's blinking now for 10 times. Thank you for your attention. I hope you had fun. That's all for the current session. In the next session, we'll learn how to write a program, a Python program on the file, and then upload it to the device. Until next time, bye.